Hi friends, let's discuss today the explain plan for this SQL query. Here I am using the same data which we discussed in the last part, that is here in the first video. Okay, I am using the same data, but here just I am changing the SQL query. I am applying a filter here for prod ID is equal to 10. Okay, let's see. Here this is the PDB. Okay, now I am executing the explain plan. Okay, it is explained. Let's check the explain plan. Okay, here this is the explain plan for the above SQL. I have copied that explain plan here in this WordPad. Let's see the indentation of these lines. If you see here, select statement from here to here and from here to here, and this table accessed by index row ID and these two are in the same indentation. Okay, so this will become the left part of the tree and this will become the right part of the tree. Okay, let's see. What is the left part? It is products. Right part is sales. Okay, this table is accessing by index. This table is also accessing by index, and top of this, which operation is performing? Nested loops. It is joining using nested loops and grouping by hash. Hash group by is happening, and then it gives to select statement. The output will be given to select statement. Okay, so if you see here, this table products is accessing by index unique scan method. Why index unique scan? Let's see. In SQL developer we will go what is this index type. We will see what is this index type. Here products table, we have only, if you see indexes, we have only one index, that is PK products index name, and it is uniqueness is unique. So Oracle optimizer already know this PK products is a unique index, so it thinks that it will expect that it will return only one value. This prod ID is equal to 10 here. This prod ID is equal to 10 will return only one value. So here see the rows are only one here. This one. Okay, 1 1. And here see why not it is index unique scan here. Index range scan is happening here. Why index range scan is happening here? Why not index unique scan? Let's see the index. What is this index type? Okay, on this sales table, if you see here, sales table, where it is sales here, there are three indexes on this sales table. We want to focus on this prod ID. Okay, is it prod ID? Yes, in IDX sales prod ID. So see, uniqueness is non-unique. So Oracle optimizer already knows that this index is a non-unique, means it will have many values which are equal to the prod ID 10 on this sales table. Okay, so it will go and use the index range scan. Okay, and it will give 638 rows from 489k rows. We know that sales table has 489k rows. Select count from sales. See 489k rows. This will give you 638 rows. It is accessing using index range scan. Okay, and here the table accessed by index row id. What it means, let's see this index, how the data is stored in this index, like in this pk products, like it stores row id. Okay, x a like this. Okay, and here our key value will be 10, 11, prod id will be 12, like this. It will have its own row ids. Okay, like this. This is actually the physical address of the, we can call it as a pointer to the actual row in a table, in the product table. Okay, this AXAA will be the actual row from this product table. Using this key value and row id, it will fetch the actual row, it will take the actual row and return the value to the end user. So what is the value here? 10. It taken the value 10 from here and it equals to the s dot prod id. So s dot prod id will also become 10 here. Okay, then it will go and search in the sales table. Here in sales table, it is accessing by index row id batched. What it means, here in sales table, sales index, there are duplicate values of 10, right? So many 10s are there. So for each 10, it is having different row id, AB, AZ, AD, like this. Okay, it will store like this. For every 10, using this row id, it will fetch the actual rows from the sales table. Okay, it will fetch up to 638 rows. It will fetch. Okay, what it actually here, 638. Using this, it will join and group by operation will performed and the result will be returned to select statement. Okay, now let's see the result of this SQL query. We will go here in SQL developer and we will paste the SQL query and run it. See, it will pick only one record of prod category and it gives the result. Okay, and next topic is any questions. So I have copied the sixth ID number here, index range scan IDX sales prod ID. So here what is the question here? Why index range scan is happening? Why not index unique scan? We already discussed, right? Because the index type is here for sales, it is non-unique index. So Oracle Optimizer already knows that this is a non-unique index. So it may contain duplicate values. So it will go to range scan here. It will go to range scan and access by row ID batched, means here p stop is based on the row ID. It will grouped by row ID first. Okay, and then it will fetch the actual rows from the sales table. Okay, so that is the answer for this question. And going for next question, how this index pk products had stored the values in it. This is also we discussed like this. So actually if we discuss some more little bit deep inside here, like product IDs, what are the product IDs? Product IDs will be like 10, 12, 11, 12, 13, like that, no? So here first will be the root. After that branches are there, then leaves will be there. Here branch, inside the index it looks like this, leaves. Okay, root will be stored like it is 10, 15, 30, 10, 15, 20. It will be equal, it will based on the internal algorithm. I am giving just example, 10 to 15, 10, 15, 20. The branch, how the branch will be spreads, this is the root. If how the branches are spread, here 1 to 10, 11 to 15, 16 to 20. And how the leaves here 1, 2, 3, 4, 5, and another leaf is here 3 leaves, suppose 6, 7, 8, 9, 10. These are equally distributed actually based on the algorithm, internal algorithm of the index. Here 11 to 15, 11, 12, 13, and leaf 2, 14, 15, 16. Same here leaf 1, this is leaf 1, leaf 2, leaf 3. Okay, here in leaf 3 will have 16, 17, 16, 17, 18, 19, 20, here 21, 22. These are equally distributed. Okay, these are the leaves, these are the branches. Internally, like this, the index stores the values. Okay, we go up. So these are the thing I explained here. Like row ID consists of this address, data file number, block number, and it will go to the actual table and fetch the data. Okay, this is the thing. Nested loops. Why the nested loops? See here, a nested loops join is chosen because the driving source product is very small. Means the result set of the product table based on that prod ID is equal to 10 is very low, right? Selectivity is less. So the result set is low, means we can use this nested loops. Nested loops will be used here for low data sets, very small data sets we can say. And for large data sets, hash joins will be happening. See, if we go to the first plan, here hash join is happening, right? Why? Means table access full, here full table is accessing, means large data set is there here. Result set is large data set, so hash joining is preferred. But here we have low data set, right? Small data sets, 638 rows only, 1 row only. So nested loops are preferred here. After that, hash group by happened on that both the tables or both the result set we can say. Then select statement will be given the result, final step. See, index selection, choose a unique scan for products, and raise scan for sales, returning many rows, which is optimal strategy for this type of query. Okay, and here p start and p stop is equal to row ID. Here you see p start and p stop, partition start and partition stop. In this, it is based on the row ID. Okay, but if you see in the previous plan, it scans all the partitions here, table access full, sales, it scan all the partitions. Partition start is start from first partition to 17th partition. Okay, total 17 partitions all scanned. But here in this, it is accessing by index, right? So it is based on the row ID. Okay, I hope you guys understood clearly. If any questions, please comment below, we will discuss further. Okay, thank you, bye bye.